So when actually we're talking about an atom's discovery was one of the greatest discovery in the whole sciences field, not just in chemistry, but for the whole science, it was a good discovery. I don't believe that the person who actually discovered this atom have ever seen the real atomic structure. It was just assumption. It was an hypothesis which was later on found perfect. It's moreover like that how the atoms are arranged. Atoms have shell, they have got the positively charged, they have got that positively charged, but negatively charged electron in the center. This was negative, the other one was positive. So what actually happens that how it was discovered, how the subatomic particles were discovered, it was about passing the beams of electron, proton, and neutron from a field, from an electric field, where they made two poles. One was positive, the other one was negative, and these beams were allowed to pass through them. The beams of proton, electron, and neutron from a source were allowed to pass through the they were allowed to pass through the electric field, and for that field, what they observe a beam of proton was attracted towards negatively charged electrode, whereas a beam of electron was attracted towards positively charged electrode. And about the neutron actually passes down straight. The neutrons move straight. And now what they observe is, they observe that the deflection of electron was more than the deflection of proton. They actually observed this, the deflection for both of these were not same. That was due to the mass. As the electron was lighter in mass, it deflects more. And the proton was heavier in mass, so it deflects less. The deflection was not same for both. As electrons deflects more than the proton due to their masses. It's because of their masses, the proton is having a smaller angle as compared to that of the electron. The electron is having greater angle. And why is that so? Because of their let me just show you how we can mark this. So you can see it over here. You can just we can just simply remove this thing. Guys, just give me a minute. All right, guys. So what do you have over here is the deflection was not same for both the electrons and the protons. So I was showing you that how the angle is working. All right, have a look over here. Let me just remove this one as well. This one as well, and this one as well. You can see that the angle between then the electron, oh sorry, then the protons is having a smaller angle. It has got a smaller angle than the other one. All right. So that is actually how the subatomic particles were discovered. And it's moreover, we can say it's always like this that the positive attracts the negative. So the proton was attracted by the negative electrode, as you guys can see over here. This was a negative electrode. And as you guys can see over here as well, this was a positive electrode like this. This was one positive attracting the negative electron. This was one negative attracting the positive electron. The issue is when the same charges are attracting each other. It's not about same always, it's about opposite attracting each other. So it's the reason why the proton is attracted by the negative electrode and the electron is attracted by the positive electrode. It's more what you can say is like this is the whole scenario how the whole world works. All right. I believe you guys are understanding what I'm trying to say. We're still talking about the chemistry of the subatomic particles. All right. So next, right after this, we have got another part of it that says for like atomic number and the atomic mass. Do you guys know what atomic number is? Atomic number, any idea about the atomic number? We just discussed, we just recently. Deflection, oh my, on my words. Okay, get back to this. Then I'll tell you what deflection is. Deflection is the curvature, or you can say that the electron beam is bending more than the proton beam. The proton beam is bending less. The proton is heavier in mass, nah? That is why. The electron is lighter in mass. That is the reason. The electrons are bending more in a beam. The protons are bending lesser in a beam. So it's about their bending, it's about their curvature, it's about that they are having, different angles of deflection due to their masses. So is it clear? The electrons are lighter, obviously. Electrons are having, I just told you guys, electrons are having 1/1840 mass as compared to proton, when it's having 1. We don't have any unit. We are over here, we are unitless. We don't have any unit. It's just a comparison we can do between the protons and the electrons. It's all about that one unit. If it is any particular unit is given to the mass of the proton, then the same unit for electron will be 1840 times lesser for it, approximately 2000 times lesser. Exactly, yes. It is also relative, yes. The mass of the proton and electron among them is relative. It's quite a bit relative. Actually, with this, let's move on, guys. We're gonna talk about what? We're gonna talk about the atomic number. Do you guys have any idea what the atomic number is? Again, we have already done this, I know, but still, what's the atomic number is? Yeah, atomic number is the number of proton it represents the placement of an atom within the periodic table. On the other hand, we've got the atomic mass. Is the sum of, or you can say a total of, let's just write sum of, it's more convenient. Is a sum of number of protons and the number of neutron. Always call it like how heavy the atom is. It's always like this, that how heavy an atom is. Okay, how heavy an atom is defined by the total number of proton and the neutrons present in it. Achha, let's just suppose that if somehow we are given the yes, beta, yes, very good. That is like yes, exactly, Muntazir, I just read out all the messages. So now you need to understand this, that this whole scenario, this whole game. So let me just adjust a few things. Okay, all right. So try to understand this thing. The atomic mass is in a periodic table is placed over here with the symbol. Sometimes you can simply have another appearance of it. How? Let me show you. Let me make a duplicate thing of it. If you just look at the, if you just look at what, if you just look at the, if you just look at what, guys, if you just look at the periodic table, what are you gonna see? Mass of 12, that's placed over here. There's atomic number of 6, that's placed over here. So it's all okay. These both are atomic numbers at this particular point and at this point. These both are atomic masses. It could be either of the presentation. All right. Are you guys good with this? You know what? I was like, when I was confused in like what's atomic mass and what's atomic number, What I do is I always say the student to, just cover up this thing, like the bigger number will always be the mass. The lesser one will always be the atomic number. The atomic mass can never be greater than the atomic number. I hope you guys understand this thing. Good to have got, let's say, for example, I always do the same. So for example, you have got the carbon represented over here. If let's suppose somehow they ask you questions, if somehow he asks you that the atomic number is there, the atomic mass is there, can you tell us what's the proton number? No, what's the neutron number in it? Guys, remember the neutron. The neutron is mass minus proton. So it's like the neutron is equals to, over in this condition of carbon, it's like 12 minus 6. That makes it 6. So it's about the super and the subscript, okay? All right, so that's all about this. Can you take a screenshot of this? All you need to do is just to write the number of electron, proton, and neutron. And there is a twist. I'll explain you this in the next class about these charges. If you can write about it, I would glad to have that correct answer from you. This is your homework. You're gonna do this whole thing. Yes, Muntazir. You're gonna complete this whole thing with the proton, electron, and neutron number. Yes, Beta, please go ahead.